Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC that is in equilateral triangle, and we know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units, and inside the big triangle ABC we have the green triangle FDE, that is a right triangle because angle FDE is a right angle, and we want to find out the area of the green triangle FDE. Okay, first of all, the angles of any equilateral triangle equal to 60 degrees. So angle BAC equals to 60 degrees, and angle ABC equals to 60 degrees, and angle BCA equals to 60 degrees, and the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. So I write it down. AB equals to BC equals to AC. Okay, but what is the size of side BC of the equilateral triangle? BC equals to BD plus DC. Okay, again, BC equals to BD plus DC. Okay, but we know that the size of BD is 2 units and the size of DC is 4 units. So actually BC equals to BD, that is 2 units, plus DC, that is 4 units. That is to say, BC equals to 2 plus 4 units, or BC equals to 6 units. So actually all the sides of the equilateral triangle are equal to 6 units, because in any equilateral triangle all the sides are equal to each other. Okay, in the next step we will define DE as A, that is to say DE equals to A, and we will define FD as B, that is to say FD equals to B. Okay, and then first of all we know that AF equals to BF. Okay, so if we define AF as X, then BF will also equals to X, because AF equals to BF. So what is the size of side AB of the equilateral triangle? from one side AB equals to 6 units, but from the other side AB equals to AF plus BF. Okay, AB equals to AF plus BF. So actually AB equals to AF, that is X, plus BF, that is also X. That is to say AB equals to X plus X, or AB equals to 2X. Okay, so we have this equality that AB equals to 6 equals to 2X. From this equality we can deduce that 6 equals to 2X. Okay, 6 equals to 2X, and if we divide this equality by 2, we will get that X equals to 3 units. Okay, X equals to 3 units, or AF that equals to X equals to 3 units, and BF that is also equals to X equals to 3 units. Okay, in the next step we will find out the size of FD that equals to A. We will find out the size of DE that equals to A according to the law of cosines. Okay, so what is the law of cosines? Okay, what is the law of cosines? First of all, you should remember that the law of cosines apply to any triangle. So we can write here that in any triangle actually, if we have triangle this black triangle, and the length of this side of the black triangle is A, or equals to A, the length of this side of the black triangle is B, or equals to B, and the angle between side A and side B of the black triangle is theta, and the length of this side of the black triangle is C. Then, according to the law of cosines, the following relationship exists between the sides of this black triangle to its angle theta. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, again, according to the law of cosines, C squared equals to a square plus b square minus 2 times a times b times cosinus theta. And it is true for any triangle. Okay? So we actually can implement the law of cosines in triangle FBD. Okay, we will implement the law of cosines in triangle FBD, this small triangle. So in triangle FBD, according to the law of cosines, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, so according to the law of cosines, in triangle FBD, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay? But what is the value of FD? According to our definition, FD equals to A, so FD square is A square, and it equals to FB square. FB equals to 3 units, so FB square is 3 square. 3 square is 9 plus BD square. BD equals to 2 units, so BD square is 4 minus 2 times FB. FB is 3 times BD is 2 times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. And what left after 2 is cancelled is A square equals to 9 plus 4. 9 plus 4 is 13 minus 2 times 4 is 6. Okay, so we got the equality that A square equals to 13 minus 6. 13 minus 6 is 7, so we can write down that A square equals to 7. A square equals to 7, so here we can take out a root out. We can take a root out of this equality, and we will get that A equals to the root of 7 units. Okay, so we got the value of A equals to the root of 7 units. Okay, so in the next step we will define angle BFD as theta, and we will define angle PDF as alpha, and we will define angle EDC as gamma, and we will also define angle DEC as beta. Okay, and we will find out the value of sinus theta according to the law of sines. So what is the law of sines? Before I explain what is the law of sines, I will emphasize that the law of sines apply to any triangle. Okay, so in any triangle, if we have the black triangle and the length of this side of the black triangle is A, the length of this side of the triangle is B, and the length of this side of the black triangle is C. If the angle between side B and side C of the triangle is alpha, and the angle between side A and side C of the black triangle is beta, and the angle between side A and side B of the black triangle is gamma, then according to the law of sines, the following relationship exists between the sides of the triangle to its angles: A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And it is true for any triangle. Okay, so in the black triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Actually, we can implement the law of sines in triangle FBD in our drawing. So, according to the law of sines, in triangle FBD, BD over sinus theta equals to FD over sinus 60 degrees. Again, according to the law of sines, in triangle FBD, the small triangle FBD, BD over sinus theta, BD over sinus theta equals to FD over sinus 60 degrees. Okay? FD over sinus theta equals to BD over sinus theta equals to FD over sinus 60 degrees. Okay? But what is the value of BD? The value of BD is 2 units, and sinus theta is the value that we want to find out according to this equality. So we leave it as it is. FD equals to A equals to root 7 units. We have already found out that the value of FD that equals to A is root of 7 units. So I write that FD equals to root of 7 units over sinus 60 degrees. And sinus 60 degrees equals to root 3 over 2. So we got this equality that states that 2 over sinus theta equals to root 3 over root 7 over root 3 over root 2. Here I will move 2 to the numerator and root 3 to the denominator. Okay, so we will get that 2 over sinus theta equals to 2 times root 7 over root 3. Okay, we got the 2 over sinus theta equals to 2 times root 7 over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. So what left after we cancel 2 is 1 over sinus theta equals to root 7 over root 3. So what is left after we cancel 2 is 1 over sinus theta equal to root 7 over root 3. Here we will multiply the equality by sinus theta, and we will get that 1 equals to root 7 over root 3 times sinus theta. Okay, so we multiply this equality by sinus theta, and we got that 1 equals to root 7 over root 3 times sinus theta. Okay, here we will multiply this equality by root 3, and we will get that root 7 times sinus theta equals to root 3. Okay, we multiply this equality by root 3, and we got that root 7 times sinus theta equals to root 3. Here we will divide this equality by root 7 in order to get the value of sinus theta. Okay, so we will get that the value of sinus theta equals to root 3 over root 7 okay, so we got the value of sinus theta. Sinus theta equals to root 3 over root 7. In the next step, we will get the value of cosinus theta by using the following trigonometric identity. Okay, we will use the following trigonometric identity in order to get the value of cosinus theta. The trigonometric identity that we will use is sinus theta squared plus cosinus theta squared equals to 1. Okay, so we will use this trigonometric identity in order to get the value of cosinus theta. Here we will subtract sinus theta squared from this identity, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this identity, and we got that cosinus theta squared equals to 1 minus sinus theta squared. Here we will take a root out of this equality, and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. So we got the value of cosinus theta. Cosinus theta equals to the root of 1 minus sinus theta squared. Okay, but we have already found out that the value of sinus theta equals to root 3 over root 7. So we can write here that sinus theta equals to root 3 over root 7 So here we will square this equality in order to get the value of sinus theta squared, and we will get that the value of sinus theta squared equals to 3/7. Okay, so we got the value of sinus theta squared. Sinus theta squared equals to 3/7. So here we can substitute the value of sinus theta squared by 3/7, because sinus theta squared equals to 3/7. Okay, and we will get that the value of cosinus theta is actually the root of 1 minus sinus theta squared, and sinus theta squared equals to 3/7. So we write here 3/7, and 1 minus 3/7 is 4/7. So we will write down that cosinus theta equals to the root of 4/7. Okay, so we got that cosinus theta equals to the root of 4/7. The root of 4 is 2, so we write it down. Cosinus theta equals to 4/7. So we found out the value of cosinus theta. Cosinus theta equals to 2/7. And we have already found out that the value of sinus theta is root 3/7. Okay, so we actually found out the value of sinus theta and cosinus theta. In the next step, we will create 4 equations from this drawing. In the first equation, we will focus on triangle FBD. So in triangle FBD, the sum of the angles in triangle FBD equals to 180 degrees. So actually 60 degrees plus alpha plus theta equals to 180 degrees. So I write it down. That will be our first equation, that 60 degrees plus alpha plus theta equals to 180 degrees. Okay, so our first equation states that the sum of the angles in the small triangle FBD are equal to 180 degrees. Okay, in the second equation, we'll focus on triangle EDC. So we will repeat on the same process. The second equation states that the sum of the angles in triangle EDC equals to 180 degrees. Okay, so actually 60 degrees plus gamma plus beta equals to 180 degrees. Again, the second equation states that the sum of the angles in the small triangle EDC equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and we will create equation number 3. So equation number 3 will be the addition of equation number 1 to equation number 2. Okay? So 60 degrees plus 60 degrees is 120 degrees, plus alpha plus theta, plus gamma plus beta equals to 180 degrees plus 180 degrees equals to 360 degrees. Again, the third equation is the addition of equation number 1 to equation number 2. Okay, so we got equation number 3 that states that 120 degrees plus alpha plus theta plus gamma plus beta equals to 360 degrees. Here we will subtract 120 degrees from equation number 3, and we will get that alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, so according to equation number 3, alpha plus theta plus gamma plus beta equals to 240 degrees. Then we will create equation number 4 that states that at a certain point the sum of the angles at the upper side of a straight line or line segment equals to 180 degrees. So if you focus on point D and on the upper side of line segment BC, you can say that gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, so I write it down. Gamma plus 90 degrees plus alpha equals to 180 degrees. Again, equation number 4 states that at a certain point the sum of the angles on the upper side of a straight line or line segment equals to 180 degrees. Okay, that is equation number 4. Here we will subtract 90 degrees from equation number 4, and we will get that gamma plus alpha equals to 90 degrees. Okay, we got the equation number 4 that states that gamma plus alpha equals to 90 degrees. So, but actually we have gamma plus alpha also in equation number 3. Here we have alpha plus gamma in equation number 3. So we actually can substitute alpha plus gamma from equation number 3 by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma from equation number 3 by 90 degrees. Okay. So we will get that 90 degrees plus theta plus beta, 240 degrees minus 90 degrees is 150 degrees. So according to equation number 3, we got that after we substituted alpha plus gamma by 90 degrees in equation number 3, we got that 90 degrees plus theta plus beta equals to 240 degrees. Here we will subtract 90 degrees from equation number 3, and we will get that theta plus beta equals to 150 degrees. Okay, so we got question number 3 that states that theta plus beta equals to 150 degrees. Here we'll subtract theta from equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, so according to equation number 3, beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Very simple. So I write it down that sinus beta equals to sinus 150 degrees minus theta. Okay, sinus beta equals to sinus 150 degrees minus theta. In order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta times cosinus alpha. Okay, so according to the second trigonometric identity, the value of sinus alpha minus beta is actually sinus alpha times cosinus beta minus sinus beta times cosinus alpha. So we'll use this identity in order to find out the value of 100 of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. So we will get that the value of sinus 150 degrees minus theta is actually sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, so we use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. So we got this equality, but what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2 times cosinus theta. We have already found out the value of cosinus theta. Cosinus theta equals to 2 over root 7. So I'll write it down that cosinus theta equals to 2 over root 7 minus cosinus theta. We have already found out that the value of cosinus sinus theta. We have already found out the value of sinus theta. Sinus theta equals to root 3 over root 7 times cosinus 150 degrees is actually minus root 3 over 2. So in total we got that 1 over 2 times 2 over root 7 minus root 3 over root 7 times minus 3 over 2 equals to sinus 150 degrees minus theta, that actually equals to sinus beta. Here we have 2 over 2, 2 over 2 is 1, so 2 is cancelled, and we have here minus times minus is plus, and root 3 times root 3 is 3, so I write it down. So we got that 1 over root 7 plus 1 over root 7 times 3 over 2. Okay, so we got that the value of sinus 150 degrees that actually equals to sinus beta is 1 over root 7 plus 1 over root 7 times 3 over 2. Here you can take out 1 over root 7 as a common factor of this expression. So all this equality equals to sinus beta. So you can write down that sinus beta equals to 1 over root 7, and we took out 1 over root 7 as a common factor, so in the brackets we will have 1 plus 3 over 2. So we got that sinus beta equals to 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2.5, and 2.5 is 5 over 2. So I write it down that the value of sinus beta is actually 1 over root 7 times 5 over 2. So we got the value of sinus beta. Sinus beta equals to 5 over root 7 times 2. Okay, so after we found the value of sinus beta, we will implement the law of sines in triangle DEC, and we will implement the law of sines in triangle FBD. We will implement the law of sines in triangle EDC in order to find the value of B. Okay, so in triangle EDC, according to the law of sines, ED over sinus 60 degrees equals to DC over sinus beta. Again, the implementation of the law of sines in triangle EDC is actually that ED over sinus 60 degrees equals to DC over sinus beta. Okay, according to the law of sines in the small triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Okay, what is the value of ED? ED equals to B according to our definition. And what is the value of sinus 60 degrees? Sinus 60 degrees equals to root 3 over 2. And all equals to DC. DC equals to 4 units over sinus beta. We have already found out the value of sinus beta. Sinus beta equals to 5 over 2 times root 7. Okay, so in total we got that P over root 3 over 2 equals to 4 over 5 over 2 times root 7. Here we can move 2 to the numerator, and root 3 to the denominator, and in the other side of the equation we can move 2 times root 7 to the numerator and 5 to the denominator. Okay, so we'll do it now, and we will get that 2 times b over root 3 equals to 2 times root 7 times 4 over 5. So after we did the simple arithmetic, we got that 2 times b over root 3 equals to 2 times root 7 times 4 over 5. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we cancel 2 is b over root 3 equals to root 7 times 4 over 5. Okay, that is what left after we cancel 2. Here we will multiply this equality by root 3 in order to get the value of b. Okay, so we get that b equals to root 7 times root 3 times 4 over 5. So we actually found out the value of b. b equals to root 7 times root 3 times 4 over 5 units. Okay? And we have already found out the value of a. A equals to root 7 units. Okay, so we actually have the value of a, of b and a equals to root of 7 units, and that is the value of b. So actually, what is the area of the green triangle? The area of the green triangle equals to the base of the triangle, that is b, times the height to the base, that is a. The height to the base must create 90 degrees with the base. And as you can see from the drawing, the height a creates 90 degrees with the base b. Okay? Okay? The height a creates 90 degrees with the base b. Okay, so the area of the green triangle is the base b times the height a over 2. Okay, the area of the green triangle FDE equals to a times b over 2. Again, the area of the green triangle FDE equals to b times a over 2, and we have already found out the values of a and b, so the only thing that is left is to substitute a by root 7 and b by this expression, and we will find the area of the green triangle FDE. We divide the multiplication of the b and A by 2, and we will find out the area of the green triangle FDE. So A equals to root 7 units, and B equals to root 7 times root 3 times 4 over 5, and we will divide everything by 2, and we will get the area of the green triangle FDE. Okay, so we got this expression for the area of the green triangle. Here root 7 times root 7 is 7, and the 4 over 2 is 2, so I will write it down. So the area of the green triangle FDE equals to 7 times root 3 times 2 over 5. Okay, the area of the green triangle FDE equals to 7 times root 3 over 5, 7 times root 3 times 2 over 5. Here 7 times 2 is 14, so I'll write it down that the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Okay, so we found out that the area of the green triangle, equals to 14 times root 3 over 5 square units. Okay, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, the area of the green triangle equals to 4.85 square units. Again, the area of this green triangle equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle, and we have here triangle ABC that is an equilateral triangle. That is to say, all its angles equals to 60 degrees, and the sides of equilateral triangle are equal to each other. That is to say, AB equals to AC equals to BC, and we also know that AF equals to BF, and BD equals to 2 units, and DC equals to 4 units. And we want to find out the area of the green triangle that is also a right triangle, because angle FDE equals to 90 degrees. Okay, so actually, first of all, we will find the size of every side in the equilateral triangle ABC. What is the size of the sides of equilateral triangle, the equilateral triangle ABC? Actually, we know that side BD equals to 2 units and DC equals to 4 units, and but actually BC equals to BD plus DC again. BC equals to BD plus DC. So actually BC equals to B, that is 2 units, and DC, that is 4 units. So in total BC equals to 2 units for plus 3 units. So in other words, BC equals to 6 units, and all the sides actually of the equilateral triangle ABC equal to each other. So AB equals to BC equals to AC equals to 6 units. Okay, so we also know that AB equals to 6 units from one side, but from the other side AB also equals to AF plus BF. Again, AB equals to AF plus BF, and we know that AF equals to BF. So if we define AF as X, then AF that equals to BF, then BF also will be defined as X. So because of the fact that AF equals to BF, then BF also will be defined as X or as X. So actually AB equals to AF, that is X, plus BF, that is also X, or AB equals to X plus X, that is to say AB equals to 2X. So for one side AB equals to 6 units, and from the other side AB equals to 2X. So we can conclude that from this equality that 6 equals to 2X, and we divided this equality by 2, and we got that X equals to 3 units. Okay, X equals to 3 units. That means that AF that equals to X also equals to 3 units, and BF that also equals to X equals to 3 units. Okay, in the next step we defined FD as A, that is to say FD equals to A, and we defined ED as B, that is to say ED equals to B, and we found the value of FD by implementing the law of cosines in triangle FDB. What is the law of sines? Actually, the law of sines apply to any triangle. In any triangle, you can say that A squared plus C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Again, in any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. So we can apply the law of cosines in the small triangle FBD. The small triangle FBD, we can say that FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. Again, in the small triangle FBD, FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. Okay, but we know that FD equals to A according to our definition, FB equals to 3 units, DB equals to 2 units, and cosinus 60 degrees is 1 over 2. So the only missing variable here is A, so we put the data inside this equality, and we got the value of A equals to root 7 units. So we found out that A is size equals to root 7 units. Okay, and then we implemented the law of sines in triangle FBD in order to find out the value of sinus theta. What is the law of sines? The law of sines states that in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so We implemented the law of sines in triangle FBD, and the implementation of the law of sines in triangle FBD means that BD over sinus theta equals to FD over sinus 60 degrees. Again, BD over sinus theta equals to FD over sinus 60 degrees. Okay, according to the law of sines, in the implementation of the law of sines in triangle FBD is BD over sinus theta equals to FD over sinus 60 degrees. Okay, we know that BD equals to 2 units, FD equals to root 7 units, and sinus 60 degrees is root 3 over 2, so we put the theta inside this equality and we found that sinus theta equals to root 3 over root 7. Then in the next step we found out the value of cosinus theta by using the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, from this identity we subtracted sinus theta squared and we got that cosinus theta squared equals to 1 minus sinus theta squared. Then we took a root out of this equality and we got that cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out that sinus theta equals to root 3 over root 7. We squared this equality and we got that sinus theta squared equals to 3 over 7. And then we substituted sinus theta squared by 3 over 7 because sinus theta squared is equals to 3 over 7. And we got that cosinus theta equals to root 1 minus 3 over 7. And in the end we got the value of cosinus theta. Cosinus theta equals to 2 over root 7, and we already found out that the value of sinus theta is root 3 over root 7. Okay, in the next step we created 4 equations from this drawing. The first equation is related to triangle FBD. In triangle FBD we can say that the sum of its angles are equal to 180 degrees. Okay, this is the first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. Then we created also the second equation that relates to triangle EDC. We can say that in triangle EDC the sum of its angles are equal to 180 degrees, so that is our second equation. Then we created equation number 1 to equation number 2 and created equation number 3. Equation number 3 is the addition of equation number 1 to equation number 2. Okay, then we also created our fourth equation that states that at a certain point in any straight line or line segments, the sum of the angles on the upper side of a straight line or line segment is equal to 180 degrees. Okay, so if we focus on a certain point, the sum of the angles in the upper side of a straight line or line segment is equal to 180 degrees. So this was the fourth equation, and after we solved equation number 3 and 4, we found out that beta equals to 150 degrees minus theta, and if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. And in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. And we found out that the value of sinus beta equals to 5 over root 7 times 2. Okay, that is the value of sinus beta. After we found out the value of sinus beta, we implemented the law of sines in triangle DEC. The implementation of the law of sines in triangle EDC means that ED over sinus 60 degrees equals to DC over sinus beta. Okay, according to the law of sines in triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Okay, the only missing variable here is sinus beta. We know that DC equals to 4 units, and sinus 60 degrees is root 3 over 2. So we put the data inside this equality, and we found out that B equals to root 7 times root 3 times 4 over 5 units, and we have already found out that the value of A is root 7 units. But we know that the area of the green triangle FDE equals to the base of the triangle that is B times the I to the base that is A over 2. Okay, the area of the green triangle equals to B times A over 2. And we've already found out the value of A and B. So we substituted A by root 7 units and B by the value that we found over, for B, and we found out that the area of the green triangle FDE equals to 14 times root 3 over 5 units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle FDE equals to 4.85 square units. Okay, thank you very much.